All right, my name is Douglas Hill. This is going to be my Module 4 demo video. For this module, I have decided to go into networking concepts. And what I've done is I have extended the code that I had written from Module 3, which was a Java project that created um, a, a class that managed a character for a game. What I've done is I've created a server that acts as an interface between two clients. In this case, the clients are going to be users running the game um, that I had made. So each side can create a character, and then the server allows combat between the two of them. Um, so just going to dive right in here to the actual server side of things. First thing that we do is we create a server port number. So this is an integer that holds a number. A server port is identified by a number from I forget where they start, but they go I think from 1 up to 50 or 60,000. And there's a specific range of numbers that are safe to use on a particular machine, and 20,000 is one of those numbers. So that's what I've given the server port. And this is a number that's going to be used by the clients to connect to the server. So the first thing that we do is there's a try block here that creates a server socket using the server port. A socket, in a very simplistic way of describing it, is like a mailbox. Something goes in the mailbox, someone grabs out of the mailbox, reads it, does something with it, puts something back in the mailbox, and then someone comes and grabs from the mailbox and it goes somewhere else. Um, Very simple way of putting it, but it kind of describes it. So the second thing that's going to be done here in this try block is we're going to create two client sockets. And in Java, this socket class here is defaulted to just be TCP. Um, if we do a datagram socket, then that's a UDP. TCP in a lot of cases is so ultimately TCP is data safe because you actually have flags going back and forth to make sure that all the data went through, whereas UDP can be faster, but it's not guaranteed to get all your data through. But yeah, so these start off as automatically as TCP. So here we have a client one socket and a client two socket. Um, then we have a nested try block here that will create input and output stream objects for each client. So here's client one's input stream, client one's output, and then the same for client two. And then these are used to actually send data out from the server and bring data into the server from the clients and back and forth. So my server, it starts the game off by initially deciding who will start, client one or client two. It creates this game data object, which is a class that I created to hold data that's modified by each of the clients. So it starts off with a health, a damage, and an attack roll. And I'll go into more in this when I actually look at the actual client side. But what's happening is this creates an object and passes it to the first player. That each player will they'll check for damage to themselves based on the attack roll of the other player, and then they'll do an attack. They'll update this damage and then pass it back. And then if the game is actually over for something, they'll do this, change this to true, pass it back, and then the game will end. So that's how it gets started. So this whole part right here just talks about is just getting the game started, sending the object to the right person. So here, in order to handle the input and output of the objects coming from the clients, I've actually used multi-threading, which is a concept that I've had in a class. So I don't know that it counts towards any kind of stretch goals or anything, but yeah, it was important to use this because initially I had just tried to get away with using a while loop, and it just hangs up. So using threads, it doesn't hang up. So here we just create a thread that each thread gets the input stream of one client and the output stream of the other, and then vice versa for the other thread. Um, in Java, the easiest way to do threading is to use a class. So here I have, where are you? Right here. So I just have a class that I call client handler. It implements runnable. So just another framework where it implements runnable, allows it to be run as a thread. And we just created some private attributes of some objects of the input stream and output stream. It gets those pretty straightforward. In here, though, the difference is we have a method called run, which is overridden because there's a run in the main framework for runnable. So we override this, and then this takes place of that. So just have a while true loop says to try. It tries to receive the game data object from whatever client it's supposed to receive from, and then it checks to say if the game over flag in the object is true, then it will break from this loop, and then it will send this object back to the other user so the other user can know that the game should be over. So this will break out of the loop, and then it will end that thread. Otherwise, it will just send the object across. So either way, it sends the object, but in this case, it breaks so that the loop will end and then the thread will finish. And then there's just some error checking. So each of those threads does that. So here's a start for each thread and then a join. So this will wait for the threads to finish. So once both threads are finished, then this try block will finish and then the server will close. So that's the quick and dirty of how this server works. Let me jump over to one of these. So this is the most of the same code from what all the same code from what I did last time. But what I have different here is I have code from line 59 down to 99. So 40 lines of code extra that it handles things that the user does when the game or for their turn, essentially. So it says you're waiting for your opponent, and then it will create an uninitialized game data object, and then it will create a boolean for the game being over and set it to false. Then have a while true loop, which basically is just polling, and it'll keep polling by trying to grab this game data object from the server here, and it will do that essentially until, because this will just block until it comes back as true, and then once it hits true, otherwise it's just null, and then it will start it'll do all these checks. So then it will jump in and look to see if the game is over. If it is, it'll tell the player that they've won because they had just attacked, pass it back to the other user. Other user says, hey, I'm dead now, passes it back and says you're won. And then you set the game is true, just kind of as a double down. And then you'll break out here. If the game is over, then it will set everything back to zeros, and then it'll end, and then this breaks this do while loop for this user, and then they're done. Let's see down here. Sorry. If the game is not over, there's a combat take damage. Really interesting function name, anyways. It returns true or false after the user does their check to see if it's if they live or not. If they live, returns false. If they lose, they die, then it returns true, and then it ends based on this. So that right there is pretty much how that's being done in this the client side. So I will do a demo real quick. So we'll start up the server. So the server is going to sit and wait for the clients to sign in. So there's going to be client 2. Do that one. And then there's client one. Sorry, bear with me. So now these two clients have just started the game. So I'm going to create a character on each one, just for simplicity's sake. And you can see this guy here. He's going second. So now he starts. So he has to go shopping. He's going to buy an axe. I'm going to leave the shop. So now his turn's over. Now the object goes back to this side. Um, so he's going to shop. He's going to buy a bow and some arrows, and then he's going to leave the shop. And now it bounces back over to this player, and then he'll attack. He'll do damage. So he'll do seven damage. He'll hit for do a roll of 15. That hit him. So he passed the object back to him. Now you can see his hit points have gone down by 7, which is what it's supposed to be. Now I'll do an attack with him. He will do 6 damage, roll a 9, he'll hit. And you can see that it passed back. Now his hit points went down, and we're just going to go back and forth until someone wins. So now we can see that this guy won, this guy lost. The game, those programs ended. Go back to the server, and now the server has ended as well. And so that is my project.